Good afternoon. My name is Stephen Lythe. I'm the CEO of Canny. Welcome to the first of 3 webinars that Canny is hosting. And we're looking to provide a step-by-step guide to developing a strategic approach in terms of achieving compliance with both Local Law 97 and FISP. I'm sure you're aware the city recently, despite the impact of COVID and all that it's done to us, has recently reiterated its commitment to maintaining the deadlines for Local Law 97. It's an ambitious new mandate, which is aimed at drastically cutting building carbon emissions, starting with a 40% reduction by 2030 and an 80% reduction by 2050. Alongside this, building owners now also have to face Cycle 9 for the Facade Inspection and Safety Program, which certainly from our point of view is a significantly elevated standard. Demands a far more detailed and an intrusive examination of the building's facade. So with those 2 programs ahead of you, where do you start? And from Canny's perspective, we believe there are significant synergies to be achieved by developing a coordinated approach to address both the regulatory requirements in tandem. Today, we're going to talk about our approach and start to ease into this subject. We, several months ago, established a multidiscipline team, drawing upon our internal architects and engineers, along with MEP engineers from MGE and other testing agencies, to allow us to achieve this sort of holistic view of what is going on in a building with respect to both Local Law 97 and FISP. We believe as a result, we're offering this end-to-end service in terms of investigation, scope development, budget analysis, construction documents, and CA services through to compliance. Our hope is that you'll find this series to be both pragmatic and insightful in developing a roadmap for yourselves as you seek to achieve compliance across Local Law 97 and FISP by 2024. As we go through this webinar, we really do want this to be a conversation, and that is the style that we'll be operating with, and we would encourage you to ask questions through the Q&A feature of Zoom, and I will interject with your questions wherever possible. So without further ado, I'd like to introduce the panel, and I'm going to pass over to John Rudisil.
Hey, good afternoon, everybody. My name is John Rudisil, and I'm a vice president here at Canny. I've been working with Canny for a little over 21 years now. My primary focus has been with ground-up new construction, including curtain wall, window wall, glazing technologies, as well as rain screen and various cladding technologies. I've also been focusing on redevelopment projects such as facade reclad and replacement. And we've been, a heavy component or a major component of our design considerations has always been energy savings and with an eye towards carbon emissions reductions. So we are now, obviously with the increased stringency of the energy code requirements and Local Law 97, we're energy and energy reduction is at the forefront of our design. But as Steve mentioned, we're also looking at the building envelopes, not just for energy and Local Law 97, but also for FISP compliance. And that's where my colleague sitting from across from me, Thomas Seminara, is coming from the existing buildings side of the aisle.
Good afternoon. My socially distant colleague, John, has said, I am Thomas Seminara. Also have been in Canny for the better part of 21 years. I have had the primary focus in my tenure here is dealing with existing buildings, Local Law 11 inspections, which Local Law 11 is now the Facade Inspection Safety Program, or FISP. And I've also spent most of my time here as part of a team that had pioneered the use of industrial rope access to conduct those inspections. We found that that format of investigation offers us a great view of the building and often offers our clients great value for their money. We've had tremendous experience in dealing with the Facade Inspection Safety Program and the evolution of that over the years. And today, hopefully, we can inform you a little bit about those changes and how they coincide with the local law 97 and energy side.
All right.
Our colleague from MG Engineering, Adam Farber, will be introducing himself and some of those.
I'll talk about how we're going to look at this local 97 from a mechanical, from the building operations standpoint. How you doing, Adam?
Hey guys, this is Adam Farber. Hope you can all hear me just fine. I run the sustainability and commissioning department at MG Engineering. We are full-scale MEP fire protection engineers. We do a lot of ground-up residential, hotels, retail. We do retrofits, office, etc. You name it, we do it in the city. My focus on this panel is really on the mechanical side. To satisfy Local Law 97 and to satisfy the energy and emissions requirements of the law, you really have to take a very strict view, both of the envelope, which we will discuss in detail in this seminar, but also at the mechanical and lighting systems in your building. A lot of buildings are running on very old or inefficient mechanical and lighting systems. Lighting has been generally upgraded throughout the city in response to a couple of local laws and frankly in response to how easy it is to upgrade lighting, but there are still a lot of inefficiencies present. And particularly on the mechanical side, what my expertise really offers this panel is a look at the mechanical, plumbing, and lighting systems in a building with the aim towards lowering your energy usage, creating efficiencies so that your emissions will go down and you'll be more in compliance with Local Law 97.
Yeah, so let's talk about kind of the overall, both Local Law 97 and FISP with regards to the timelines. And really the reason why CANI is and MG Engineering are looking at this collectively is because, as you can see, the timelines for both of these requirements align. As you know, Local Law 97, and Adam, you can speak to this, is the carbon emissions reductions. And there's a goal for 2024, subsequent goal for 2030. Perhaps you can just elaborate a little bit on what's going to happen over the next couple of years with regards to Local Law 97.
Yeah, so I'll talk about that briefly. Local Law 97, the very short story of the law, most people in the city by now are somewhat familiar with it. So I'm not going to go into spectacular detail, although, I'm happy to answer any questions during the Q&A if you'd like. But the very short story, it's a city law. It's a little over a year old at this point, but it takes effect in 2024. And what the law does is it caps your greenhouse gas emissions for any building in the city over 25,000 square feet. What greenhouse gas emissions means is really it limits the amount of energy your building can use. And the limit of the energy limit that your building has will be determined by the building type, the usage classification, that is, by the building size, and by the energy sources. So if your building is a commercial building, 500,000 square feet, that runs on electricity and Con Ed steam, you will have a certain amount of greenhouse gas emissions that your building is allowed to create. And if you exceed that limit, there are pretty strict fines, which I believe we'll get into in a future slide. So I won't get into that now, but the very short story is you want to stay under that limit. You want to find out what your limit is, and you want to stay under it. One important element of the law to note is that these limits drop every 5 years, starting 2024. So in 2024, your building will have a certain limit of energy usage. In 2029, that limit drops. In some cases, specifically for commercial buildings, the limit almost drops by half. So it is a very significant drop by 2029. In 2034, the limit drops again, and then again in 2039, all the way through 2050, which is the extent of the law at this point. So you really do have to take a very serious look at your building. You want to look at future-proofing your building. A lot of buildings will be in compliance with the 2024 limits that their buildings have, but they may not be in compliance once the limits drop for 2029 or beyond. And so it's worth looking at the entire building down into the future and taking a holistic view, which is what we'll get into, in order to really future-proof and take a full-scale look at the building's energy usage.
Yeah, and alongside this, is FISP. Yeah, and right, Thomas. So right now we are in cycle 9.
Yep, we're currently in
FISP, formerly Local 11. I'm sorry.
Yep, we're currently in cycle 9. It started February 2020, runs through February of 2024. Parallel paths with local law 97 threshold requirements and changes, and cycle 10 subsequently again starts in 2025 through 2030, which again parallel paths with the next ultimate change in the local law 97 thresholds.
And one of the key things about FISP that we'll get into detail in a minute or two is in terms of like the FISP just became much more stringent.
Yeah, right. Cycle 9 reporting requirements have changed drastically from cycle 8.
Most notably, like the number of jobs we have to do, the physical hands-on inspection facade, right?
Yeah, so previously we were required to do a single drop on a representative portion of the building.
Right.
That has been expanded to a drop every 60 feet and on every street side or public right of way. Right. So even if you have a passageway, a courtyard, rear yard that has public access, every 60 feet you're required to do a drop. Compounded by if your building happens to be a cavity wall building, you have to do probes that correspond with those drops as well.
We've got to verify, actually physically verify the accuracy of wall ties, and then we'll get into that a little bit more. But it really has a tremendous impact on those cavity wall types of buildings. And so, while looking at this in upper level, another thing that we are keeping in the back of our minds as we're doing these investigations is the New York City energy codes. New codes were implemented back in May that are much more stringent. Again, that's aligned with the goals of Local Law 97. When we're analyzing these existing building envelopes and mechanical systems, I mean, we're keeping the new energy codes in mind in case when we have to do some significant upgrades, either mechanical system upgrades and replacement,
or window or facade upgrades.
Window facades. Whatever we do, the implemental building is obviously going to have to meet current energy codes. So let's talk about what's the actual investigation. What's actually involved, and how do we get started? How do we tackle this? And how do we tackle both on a parallel path, and why?
Right. Well, yeah. So what we're proposing is kind of joining forces of 97 and 11 as far as the overarching responsibility for both those things, and preparing a report that addresses all of those.
Well, we want to get an understanding, right? Owners want to know, all right, well, where do I stand with Local Law 97? I'm just now learning what it means, but so when we're looking at a building envelope for Local Law 97, we're obviously going to do an exterior survey because we have to gain an understanding of how, what the conditions are and how it's performing thermally. And the way we do that is not just a visual investigation, but also on-site testing. We work with a number of testing agencies. We work with companies like Building Envelope Testing, where they'll actually come out on site and measure, to do air infiltration testing, do water penetration testing, because leakage is a FISP consideration, right? We have to identify how the building is doing in terms of water penetration for FISP. But really, the only way to really get a true reading on energy is how much air. We have to quantify how much air is infiltrating through the building envelope, because that dramatically impacts
heating and cooling costs.
Yeah, right. That impacts the loading. So we're going to do some actual testing and measuring, and then we also do some probes. We do some roof probes, facade probes.
And that gives us
that also aligns with FISP, because particularly the cavity walls, you have to open up the wall and do probes. But we want to do some probes so that we can develop some section details to analyze in terms of thermal performance, whether we're doing therm analysis or Wolfe analysis. We really need to gain an understanding of how a building is doing in terms of R values, U values.
Right, that's all dependent upon the materials that were used in the original construction.
Exactly.
Right. So understanding what the backup wall is comprised of, the facade, face brick, the integration of the wall to the windows, if those are sealed off, and all the underlying elements that contribute to air and water infiltration, and subsequently the thermal efficiency or inefficiency of the wall section.
Well, yeah, because these cavity wall buildings in particular, from the 1950s all the way up to the early 2000s. You open those up, what are the odds you're going to find a continuous air moisture barrier? You're not.
Right.
Insulation in the cavities? You're not. So that's a huge energy suck right there. And so on a parallel path, while we're climbing on the outside of the building, Adam Farber, you and your team are inside talking to the building operating engineers and conducting your investigation of mechanical systems, right?
Yeah, so as I mentioned earlier, my focus and MG's focus, since we're mechanical, electrical, plumbing engineers, our focus would be on those systems and looking at the efficiencies that are available for your building in those systems. So we're going to look at primarily the lighting and the HVAC systems, which will include water heating as well. When we look at a building, we'll look at, obviously, we want to focus on, see if there's any low-hanging fruit available for your building. This is always something that you want to
Adam, I think, one of the things that we're talking about here is, we're calling it a, ASHRAE has what they call a level 1, right? A level 1 ASHRAE assessment. Right. But we're actually, we're doing a deeper dive than that. And I think we have to do a deeper dive in order to give the building owner the true data. We're really calling it an enhanced level 1 ASHRAE, right?
Yeah, a level 1 audit is pretty top level. You're not really going to take measurements of your equipment. You're not necessarily going to model the usage of the equipment. And that is really going to leave out some significant areas of potential savings, such as controls or scheduling or usage patterns in the building. You walk into a lot of buildings and the lights are designed to turn off when everyone leaves the room, but the maintenance staff is a little uncomfortable, so they just leave the lights on 24/7. And the building, what that means is the building was designed very efficiently, but it's not being operated very efficiently. That's something that may not be able to be picked up on a very top level, ASHRAE level 1 analysis. But we make sure in our analysis for your building that we really hit those points, because those are areas that efficiencies can be gained at super low cost to the building. And a lot of energy savings, which really translates into greenhouse gas emissions, can be achieved. And so you want to look at these low-hanging, these easy-to-accomplish patterns, and some of them may involve some cost, such as upgrading equipment controls, but they'll be relatively low cost in the building. We are obviously going to look at upgrades that are going to have a quick payback or a very high ROI, or something that's relatively easy to implement or even no cost to implement. We may, in some cases, and I don't want to leave this out, that we also will want to look at higher cost or more intensive upgrades because the building may warrant it. A lot of buildings can have great success on these low-hanging fruit. A lot of buildings have already looked into that. Or the low-hanging upgrades simply aren't enough to bring the building in line. And I believe we're going to get into in the next slide or the following slide, we're going to get into an example of a building that we've looked at that's going to need much deeper, intensive upgrades. And we'll look at those. Your building may be operating on very old equipment, an old chiller, an old boiler plant. It may be operating on an energy source that really performs particularly poorly for local law 97, such as number 2 oil or number 4 oil. Those sources you may want to get off of. That's not a no-cost investment, but it's something that you've been thinking about for a while. And now with the impending fines of local law 97, there's suddenly a payback and there's suddenly an ROI for that investment. So that's definitely something we'll look at. I'm going to briefly mention, I'll get into, since I'm kind of on a roll here with talking, I'll get into very briefly the next couple of bullet points, which are the energy use and cost analysis and the carbon emissions analysis, which is something we absolutely have to look at for your building. We have to look at the energy usage, which can be obtained almost always from your utility bills. You can use local law 84 data, but I prefer strongly not to for a number of reasons, which we can get into. But really, it's not super difficult to look at your energy usage in some cases, and then to ascertain how far you are over your building's limit. If you're barely over the limit, then perhaps all you have to do is turn off those lights in the common areas that the building maintenance staff is leaving on, and you're in good shape, at least for the next 5 years until the limits drop. And so that's something you want to look into. If you're significantly over the limit, which unfortunately some buildings in the city are, then you're gonna have to think more intensively about what you want to do with your building. We're going to get into
You got to understand what's driving that. And the whole purpose of this analysis, if you have massive amount of energy usage and huge carbon emissions, well, it might not just be mechanicals. If you're dealing with 1955 or an early 1960s curtain wall that has 1/8 inch thick monolithic glass and uninsulated aluminum spandrel panels, well, there's a huge energy factor right there. I mean, that's where, again, this is where it all comes together, where you need to have, or building owners really need to have as much qualified data as possible in order to make intelligent capital improvement decisions over the next 5 to 10 years to deal with these two laws. I mean, again, so while you're doing this deep dive analysis in terms of mechanicals, further to the dovetailing FISP back into the picture here, we're on the outside of the building doing probes, because we have to do probes now for capital buildings.
In some instances, yep.
But the increased frequency of inspections allows us to really get a real in-depth look at the building envelope.
And this all is really supportive data in the approach that we're recommending that buildings look at the entirety, they look at the facade, look at the mechanical systems, and plan.
Right.
And plan now for 2024 and 2030, because the integration of some of these major capital improvements can be costly, is time consuming, and when the crunch time comes around 2028 and 8,000 buildings in the city who are failed to make the grade are suddenly trying to upgrade their facades, labor is going to be limited, material is going to be limited. It's just going to be a bottleneck for resources at that time, and we really feel that it's important to get.
You got to plan now.
You got to plan now. You got to budget now. You got to plan now. I mean, 4 years is going to be in a blink of an eye, and then 8 years down the road, when we get to the point where we're just about at that threshold, it's critical that
we get ready. Well, let's look at what some of the potential financial impacts are here with regards to Local Law 97. So, I mean, just administratively, Adam, you could speak to some of the, in terms of Local Law 97, why don't you go ahead and just talk about some of those, what the law has in terms of potential fines and reporting mandates.
Yeah, it's right there on the screen. It's you want to report, because if you don't, then your building is going to be fined 50 cents per square foot per month, which is an enormous fine. If you think of, I don't know, a smaller, let's take a smaller building, a 50,000 square foot building, that's a $25,000 fine per month. So not reporting will lead you to a $300,000 annual fine. So you want to get your report in, and it's not super difficult to compile that information. So there's really not any reason not to. Exceeding your emissions limit, which I mentioned before, and which we'll give an example of in a coming slide, is going to be $268 per metric ton over your emissions limit. I'll explain what that means. It's a bit of an obtuse number. So when we get into our case study, it's a little easier to understand that.
And this is starting in 2024.
Starting with your 2024 data, which is reported actually in 2025. So yeah, starting about 5 years from now, a little under 5 years from now, that would be your fine. The false report, if you falsify your info, there's a significant fine. And I just want to mention very briefly, I want to touch very quickly on Local Law 95. Local Law 95 is, one thing that we're not talking about much in this seminar is the soft cost of knowing that your building is in bad shape. There's a big push in the city to have people very cognizant of their energy usage and their building's energy usage, which is exactly the goal of Local Law 95. That's the energy letter grade law, which just took effect a couple of months ago, that buildings now have to post their energy grade in a conspicuous space, a visible space in the lobby of the building. And this is really connected. The info that you derive your Local Law 95 score is actually very similar to the info you'll use for Local Law 84, which is the benchmarking data. It's exactly the same info. And it's similar to the info you're going to use for Local Law 97, which is your energy usage. So these all really kind of play into each other. And even though it's not a hard cost of Local Law 97, it does bear mentioning.
Oh, and likewise, the Cycle 9 changes for FISP mandate that the ownership post the grade of the FISP report or the status of your FISP report, likewise in your lobby at the front entrance of your building. Yeah, so similar to the local 95 for your energy, you're going to have an A grade for energy. You're going to have hopefully a safe filing for your FISP program. That's what all your tenants would love to see.
Sure. But you don't want to walk in the lobby and see a D on energy and an unsafe status for local law.
Right. Huge effects on marketability and potential downside for financial impact that's not really tangible.
Right.
As far as the dollar value is concerned, or a fine chart, or but the inherent appearance. For people who have multi-million-dollar apartments and they see,
or Class A office buildings, right?
Yeah.
So, I mean, and so in terms of at the bottom of this particular page here, it looks like when you do a cursory review, and I'll stress a cursory review of the benchmarking data, the energy benchmarking data, which Adam touched upon, does need to be verified. It looks like the number of buildings that could be potentially facing fines for carbon emissions is a little over 2,000 in 2024. And then that number greatly goes up to 10,000 or more once you go into 2030. So, I mean, so let's talk about, a typical building, for example. What does this all mean? If we could move on, there we go. So Adam, you and I both looked at a building, an Upper East Side cavity wall building, about 13 stories. It's a big building, a little over 440,000 square feet. It's a rental building. It was the 1960s, like we said, 1960s cavity wall construction, and he did a cursory energy review. Why don't we talk about what we found when you looked at that, and then Thompson will touch upon what we looked at for facades.
Yeah, I'll talk about this building very briefly. As you can see the bullet points, so I don't have to go into great detail about the building, but it's an older building. It has not been significantly upgraded since construction. Since it was built, it hasn't been really, it's been maintained, I would say, reasonably well. But
yeah, from the facade point of view, we would say it was, I mean, they kept it within legal compliance.
Yes, yeah, it's reasonably fine. As my understanding is, the residents don't complain that much about their comfort levels. So when you're talking about the facade, it's not particularly drafty. Right. The windows aren't particularly leaky. The heating and cooling systems more or less work. I don't believe there are central cooling systems in this building. There are window units for tenants residents who want them. But I'll go through the numbers on the right side of the page pretty quickly. This is a pretty top level analysis of the bills and data that we are going to use. This is a top level analysis. We're going to get in a good deal more depth. And, obviously when we look at your building, but this is a building, as you can see from the top two lines, it runs on electricity and natural gas. They use a lot of both. The building is about 429,000 square feet. It's a class R2 building, typical residential. There is, if you look at the next section below, the next section is class M. And that's because there's ground floor retail in this building. So different sections of the building with different usage classifications do have to be graded slightly separately. And the reason is the limit for a class M building for greenhouse gas emissions is higher than a class R2 building, and you want to give the building that allowance. And if you would rank the entire building by class R2, then it would be even farther above the limit than it is right now. But as you can see, going down into the third section where it says building 2024 limit, which is 3,070. That's in metric tons of carbon dioxide. That's your emissions. So this building, based on its size and based on its usage class, is allowed to create a little over 3,000 metric tons of carbon dioxide emissions. That is a hard number for this building, and there's not much way around that number. How you get to the number immediately below it, which is your actual usage, depends on how much energy you use and what types of energy you use. As I said, this building is running on electricity and natural gas. Some buildings will run on steam, number 2 or number 4 oil, etc. And so those buildings will have different calculations that are shown, but this is, again, this is a reasonable sample. So this building is using just under 5,000 tons of energy, or excuse me, this building is creating just under 5,000 tons of carbon dioxide emissions,
Right.
which is about 2,000 tons over their limit. As you can see in that line, they're 1,869 or almost 1,870 tons over their limit, times $268 per metric ton. That's the number that we mentioned before. As I said, it's a bit of an odd number, so it's easier to conceptualize in this context. That leads to an annual fine of $500,000 a year over 5 years. The 5
Right.
years would be starting from 2025. So every year, 2025 through 2029, you will be hit with a $500,000 fine, assuming your usage doesn't change significantly, right? If you
Right.
if you have half of the apartments as vacancies, your energy usage is going to go down. If everybody's staying home because now all of a sudden everyone's working from home and they're in their apartments much more, your usage will go up. And these are things that you really have to consider. And this is not assuming any significant changes or modifications to the building systems or envelope. This is the building as it is now. So you can see that this building is on the hook for $2.5 million over a 5-year period, assuming the usage patterns stay relatively the same. Starting in 2030, when the limits drop, their fine goes up to about $840,000.
Right. It gets even worse, right? And then on the parallel path there, not only are you looking at a $500,000 fines starting in 2024, but right now the building is looking at about $1.7 million worth of building envelope repair work. Right,
And that repair work is going to,
well, we got shelf angles that need to be repaired and or replaced in some cases. There's cracked brick masonry.
water leakage infiltration that we're going to have to correct.
Parapets need to be replaced because there's leakages obviously where the roofing meets the perimeter walls. There's through wall flashing deficiencies. I mean, it's an over 50-year-old building here. So, and by the way, once the owner finishes doing $1.7 million worth of repair, sure, they get a safe FISP, but it does absolutely nothing for the energy. Now, this is the 1960s. There's no insulation in this cavity wall. There's huge air infiltration coming in through the masonry walls. And this is something that the owner's going to have to look at. Once we get out of cycle 9, then in 2025, it kicks off cycle 10 FISP.
And what we find, and I'm sure as building owners, representatives, and managers, that you'll see, this is a reoccurring theme, right? Every 5 years, more often than not, buildings of this vintage are putting $500,000, $1 million, $2 million into repairs on a recurring basis, impacting tenants with sidewalk bridging and scaffolding and closing off terraces and balconies and such. So you have this tremendous negative impact to the community that lives in the building.
Intrusion on the property.
Yeah, and you have this, outlay of cash that all it does is keep the building safe. Now, obviously, keeps the public safe and maybe corrects some water infiltration problems, but you're not really making the building better. Right. So by thinking about this plan and understanding what needs to be done and to mitigate the huge fines that are coming down the line, this particular example may be a good candidate for a facade recladding. And, granted, a facade recladding may cost $10 million. However, you're offsetting the cost of that.
Well, that's why we're looking at these like 10 years out, right?
Yeah.
There's things that we can do to stabilize and make sure facade, get the building safe, right? And then on a parallel path, like Adam, what you talked about, there's low-hanging fruit, quote unquote, that we'll look for on an energy side to get through to get to 2024 without incurring huge fines, and really buy some time to do some strategic planning for 2030. And that's where, look, some of these buildings, you'll never stop putting money into these cavity wall buildings, and you're never going to be able to put insulation into them without reskinning them.
Right.
So
we got a plan.
I got a couple of questions from attendees. The first question, just asking for clarification when the requirements and the results of both Local Law 95 and FISP need to be displayed in the lobby. When does that need to occur?
As it relates to FISP, when you get your approved report back for cycle 9, at that time, you should be posting your letter grade upon approval of the report.
Now, the cycle, there's there's sub-cycles, right?
Correct.
So, I mean, some people are going to have to start doing this at the end of sub-cycle A, which is
2022 is the deadline for sub-cycle A. February 2023 is this deadline for sub-cycle B, and 2024 for sub-cycle C.
Yeah, so it's a function of when you can file, right, for your by virtue of your sub-cycle, and when you get, like Thomas, you said, when you get that approved.
When you get the final approval, I should say the accepted report.
And for
Adam, can you speak to, go ahead, sorry.
Yeah, local law 95, which is the energy grade, the energy letter grade score, that you have to post it by November 1st of this year. So you've got, looks like about 3.5 months, and it relates to your 2019 energy utility data.
Great. Another question actually directed to you, Adam. The original local law 97 applied the highest greenhouse gas multiplier to electricity. The questioner is asking, aren't we supposed to be moving towards electricity?
Yeah, the city is undergoing a push to move towards electricity. And the reason is that electricity is the fuel source that can be generated by renewables. All other fuel sources, you know, are I shouldn't say all other, but essentially all other widely used fuel sources in the city, which are natural gas, oil, and steam, are generated by non-renewable sources. Even natural gas, which is relatively clean, and can be used in even cleaner ways, such as cogeneration, it's not a renewable resource. So the city does want to push us towards electricity long term. The problem with that is that right now the electric grid in the city just can't handle it. If we were to electrify the entire city tomorrow, it would shut down. It couldn't. There's no way it can handle the wattage load of the city. So the city's goal is by 2050, which is the end goal. And Local Law 97 and Local Law 95 are two really small pieces of this overall push that the city has to both move everyone onto electricity and make the electric grid more stable and sourced from renewables. That's the goal eventually, so that by 2050, I think the city's goal is to have 80% of total energy used in the city come from renewable sources. And the only way to do that is to have the grid, the electric grid, upgraded so that it can handle 80% of the energy in the city. And right now, electricity is not quite 80%, it's not close to 80% of the total energy in the city. So the city's penalizing electricity right now because for the time being, for the next 30 or so years, the grid needs time to catch up, both in terms of its capacity and in terms of how energy is sourced, meaning from renewables. But eventually, and this is one of the reasons that the city hasn't published, you know, if you look at the current slide, you'll see the building's 2024 limit and the building's 2030 limit on this slide. And those are based on the 2024 and 2029 emissions caps that the city has published. The city has not published emissions caps beyond that date yet. So we don't know the 2034, 2039, et cetera dates. Limits, excuse me. And the reason is that the city is trying to, we know it's a moving target because we want to get people moving towards electricity, but we can't get people moving towards electricity until the grid can handle it. And so that's really the reason, and that's the reason that right now the emissions cap for electricity is high. But eventually the goal, exactly as the questioner asked, and the questioner is correct in the assumptions in the question, the goal is to move towards the city towards electricity.
Thanks, Adam. Just a reminder to anybody attending, the Q&A is open, so you can just ask a question, and we're happy to address this. And the follow-up question to you, Adam, came, so are we supposed to electrify to meet 2050 but be penalized in 2030? I think, you know, as you're speaking to here, there's this sort of this gap in desire and expectation that is challenging.
Yeah, that's true. I wish I had a better answer, but we're dealing with the city government here. So it kind of is what it is. The justification that I have been given by various people who know a lot of the thought behind the law is that over the next 30 years, your building will likely have to make significant upgrades anyway, and likely more than once. You'll have to invest significantly in the building. And so the thought is, if your building is over the emissions limits now, then you may want to get on some efficient natural gas equipment, let's say, to keep yourselves at a low local law 97 threshold. But over the next 30 years, that equipment may have to be swapped out, and that'll happen as the city publishes the future emissions limits.
Okay. And maybe somebody was just asking, could you just recap what the first step would be to find out the energy output for a building and evaluate what they need to get done, whether it's immediate or long-term? So what is that first step?
Yeah, absolutely. The first step is really a twofold step. They're kind of two parallel first steps. One of them I'll talk about, and the other one is going to be split between me and John and Tom, who we're going to speak as well. But I'll talk about part two of this step, which is the easier one, I think. Although not in many buildings. The part two is to look at the building's energy usage. So you're going to want to look at the electric bills, the natural gas bills, steam, etc. for the building, and that'll tell you the energy that the building is using. I should note, and I should clarify, this is a question that's come up a bunch of times, that the energy usage of a building encompasses all areas of the building, and that includes sub-metered or separately metered areas. So natural gas and steam in your building are almost always going to be master metered, but electricity might not be. You may have tenants that are on separate electric bills. You may have residents, if it's a residential building, and you never see their bills, ever. A lot of buildings are totally separately metered, and building management or ownership will never see the utility bills of those residents. You have to now. You have to gain access to those bills because Local Law 97, you have to analyze and publish the total billing. So step two in the first steps analysis is going to be for you to gain access to all of your building. As you can see, the building that we have shown on the screen here, that last bullet point in the first section, it's master metered for electricity. So this is a building that's relatively easy to analyze the billing. But as I noted, some buildings will not be, and we could discuss that offline if that's a particular concern in your building. That's step two, is to do this billing analysis, to do essentially the analysis that we have shown on the screen here. Step one, I'll let the guys from Canny speak to, because that's really going to be the on-site assessment of the building and its systems.
Before you go on, though, just to follow on to that, somebody's just asking, so essentially all the loads that are plugged in the spaces within the building are going to be counted, because you need to, whether it's separately metered or not, you need to understand the load across all space within the building. Yeah,
there's no way around it. If a guy plugs in a hair dryer, then that uses energy. And unfortunately, there's just no way around that for your building's analysis.
Right, and so once Adam, once you say, hey, okay, your building is using X amount of energy, and then the question becomes in terms of, well, what do we do about it, immediate and down the road? Well, we have to understand why, right? I mean, the building uses a lot of energy. Why? Some of it's going to be because of just how the building is operated, old, inefficient equipment, and then that's where the building envelope comes in. It comes big time because how much air exchange?
Right, air exchange.
How much energy is going out of those thermally inefficient windows, or these exterior walls that are not insulated, these 50, 60, 70, 100-year-old walls. I mean, in order to tell someone, I mean, you can tell them, here's where you stand in terms of the volume of energy that you're using, the amount of carbon emissions that you have, but what do you do about it? That's where we feel really strongly that you have to look at this holistically. You've got to look at not only just the building, how it's operated and the equipment, but the envelope.
And you have to be smart about the repairs that you make to the envelope, because you can't just seal up the building and insulate it and think and everything's going to be okay, because what you wind up doing is creating condensation issues, because you change the dew point in the wall. And if you don't do this the right way, you may save energy, but you're getting mold on the interior side of your sheetrock now, because
that's of course, yes, exactly. You got to be careful about what exactly you do. But Go
So
ahead.
this is all good stuff, but we are actually approaching the end of our time together. So perhaps across the three of you, you could just try and wrap things up. We're certainly prepared to stay online afterwards and answer any other questions. But John, Thomas, and Adam, could you just pass on your
Yeah, I
final
mean, you know, the next step. So I think what we're collectively trying to summarize here is that we've got local law 97. I hope that we've really, hopefully, provided some insight into how you approach that. And we've got this fifth going. But the next step really is in our next webinar is going to be talking about what are options, you know, providing some case studies. We've got a lot of buildings that have big problems with FISP and on a lot of money that needs to be spent over the next 5 years for FISP, as well as local 97. Our goal here is to really help building owners identify where they stand today, and do some strategic planning to get not just 5 years down the road, but certainly by 2030, because we know where we need to be in 2030. And then just really reposition these buildings to be able to deal with this, particularly financially, especially now. Now more.
So in the third part of our webinar series, we're going to be talking about the PACE financing and other tactics to minimize the cost of these upgrades and try to
what kind of incentives?
help our clients mitigate the impact. Just wanted to take a moment to thank everyone for attending. We appreciate your attention. And hopefully we'll be doing these live at some time in the near future. But for now, I think this format is working really well, and we look forward to having you here on the 17th, I believe, for the second part of the series.
Yeah, so look out for the invite. We're timing it for approximately in 2 weeks' time. I do want to thank John, Thomas, and Adam for their insights today, and likewise for attendee questions. Certainly do feel free to follow up with us with other questions. No matter how trivial, we're really very happy to engage in some dialogue on this, and there will be a recording of this session available at the end. So thank you very much for all attending, and have a good afternoon and good weekend.
Thank you all.
Thank you.
Can you mute me?